Hi everyone, this is going to be our pre-lab lecture on the copper cycle. So this is going to be our second lab report for the semester. So again, like the last pre-lab lecture that we had, it was originally intended for us to be actually running the experiment, but I will be sending out the process, well, not the process, but the raw data later today. So let's talk about what our ultimate goal is. So first off, even though the name of the lab is called the copper cycle, right? It is not a quote unquote thing. It is not something that all scientists know. It's actually just a series of reactions that have been designed so effectively they form a cycle. And so what do I mean by that? So our first reaction, reaction 1, is going to be taking solid copper. It will undergo a reaction to form the copper 2 plus cation. How that happens? Well, we would be reacting it with nitric acid. Once everything has been converted to copper 2 plus, we would perform a second reaction immediately on the first, in which we would add sodium hydroxide. In the case of that reaction, it would convert the copper 2 plus to copper hydroxide, which is an insoluble solid. And you would actually see this precipitate out, and which I will abbreviate as PPT. And so that's the common abbreviation. I know it looks like PowerPoint, but it's the abbreviation for precipitation or precipitate. And precipitate means a solid that forms from something that used to be soluble. After that, that compound would then be heated. Upon doing so, it loses water. It's dehydrated. And it's going to form a black compound. And there's a reason why we actually have some of these colors in here. If maybe I probably should go back and look at that. Copper is roughly copper colored. After we mix it with nitric acid, it turns a blue to greenish color. When we precipitate it out with sodium hydroxide, it is a blue color. When we heat it, it will turn black. We'll take that black precipitate, the copper oxide solid, treat it with sulfuric acid, and actually what it will do is resolubilize it, forming a new compound. Even though we only have the cations here, technically the one on the right would be copper nitrate, and the one on the left would be copper sulfate. Oops, let me do that right. And both would be aqueous. The very last thing we would do is, once we have our copper sulfate solution, which will in fact be blue, you would add zinc solid to it, which then would force a redox reaction to happen, and it would reduce the copper in copper sulfate, which is in the form of copper 2 plus, back down to copper, effectively completing, oh my god, there we go. Completing the cycle is what I was trying to get to. And so that's the idea behind the copper cycle. So this is a little bit more detailed on the particular reactions we would be completing. I'm going to leave this up to you to go through, since I just kind of spent your time already talking about the individual reactions. But we can see here, there's our copper with nitric acid to form copper nitrate and some byproduct. That copper nitrate reacted with the sodium hydroxide to form copper hydroxide with some byproduct. The copper hydroxide is heated to form copper oxide and some byproduct. Copper oxide is treated with sulfuric acid to form copper sulfate with a byproduct. Copper sulfate is reacted with zinc to form zinc sulfate, and then we've completed our cycle now. Because what I ended with was copper solid, and copper solid is what I began with. This is the idea of the cycle. So, things to pay attention to. So, if we were doing this experiment, would be to be recording observations carefully. Oops, Let me switch back to my highlighter. There we go. Recording observations are incredibly important for scientists, which is funny because maybe back in my day watching like the Mythbusters and stuff like that, the difference between science and screwing around is writing things down. As much as it sounds dumb, it actually is true. So writing things down is how you start to pick up on patterns, right? And doing this experiment, you're looking for patterns, right? Another thing, this is going to be important for writing for the lab report, and it's a little bit more difficult when you don't do it yourself, but thinking about how could sources of error pop up during the course of the experiment. So go through, and you're asking yourself mostly why, right? Think, how would, if I was doing this experiment following the technique, and you absolutely must look at the lab manual to do that, because other than that, it's just nothing. It's just words, right? So make sure you're reading your lab manual and think, where would the sources of error be? And then this is for any time you do science. Again, it's almost like when I was talking about, recording things versus screwing around. Making sure your notes are clear. Oops, sorry. Playing with some of the settings. There we go. Keep skipping. Hold on, let me just do this. There we go. All right. So, to go quickly through the reactions, which I've already done. Actually, I probably don't need to do that again. I will go through these slowly. If you've already said, hey, I got it, then just ignore me, and then you can skip down towards the end. But again, we're starting with copper. We would add enough nitric acid to convert all the copper to copper nitrate, and we would produce two byproducts. One is actually a toxic gas, and so if we were doing this in the lab, we'd actually have to do it in the hood, because it does produce a brown gas, and it's toxic enough that we have the standing rule that if you do this experiment outside of the hood, you immediately go home and get a 0 for the whole day. So, put it this way, if you breathe in NO2 into your lungs, it turns into nitric acid. So basically, there's some of the summaries right here, but things we need to think about, right? Well, there we go on that one, but I guess it's not written here, but this is something to think about in the future when we get to week 2, but how do I know the reaction is complete? I'll leave that up to you to figure out. How am I going to figure out the reaction is done, right? I'll give you the heads up. Something about generating gas might be part of it. So again, if we were doing this as a real experiment, excuse me, I'm going to cough for a second. Again, I tell every student that I have that it's just from talking all day. I've been on Zoom for 5 hours, so my throat's a little dry. So forgive me for that. All right. So if we were doing this in real life, we'd be following all of this, right? So we want to make sure we're recording things and then we're answering certain questions that we have. So what type of reaction is this? I'm going to leave that up to you. This is for you to figure out. Take a look at this. What type of reaction is it? Because, well, actually, let me do this. See if I can switch. Nope, it'd be too difficult right now. So I will do it in a different document. But think about the types of reactions that you know, right? Is it a double replacement? Can't use my stylus right now. Right? Is it a double replacement? Is it a redox? Could it be single replacement? Could it be an acid-base reaction, right? There's a lot of different types of reactions that you know. So I'm going to leave that one up to you. Reaction 2, again, I don't want to waste your time because we've already kind of gone through this in terms of the cycle, but there's our product from the first reaction, And what we'll immediately do is react it with something else to create this second reaction to produce the product that I want, which is copper hydroxide. When we do this, we would usually check the pH of the solution. When you have a pH greater than 7, it means the solution is basic. What do I mean by that? It has a high concentration of hydroxide anions in it. And in this case, because I'm adding in sodium hydroxide, once all of this copper nitrate has been reacted, the only thing left for this sodium hydroxide to do is when you add it to water, the sodium doesn't really do anything. All it does is create hydroxide, so it makes the reaction more basic. So the way we'd usually go about things is to use pH paper. So if there was any copper nitrate, everything would just be reacting with that hydroxide, the sodium hydroxide, and there'd be no change in pH. As soon as I run out of this reactant, all of a sudden the pH paper is going to start showing that it's basic because that sodium hydroxide I add has nothing else to react with. It just turns into more hydroxide. And so I'm going to leave the rest of that up to you. Reaction 3, again, we're going to see this continuous pattern. There is the product of my last reaction. Heat's not necessarily a reactant, but it's a stress we could put on the system. Well, in that case, it's going to convert the copper, the hydrated copper, well, that's copper with 2 waters attached to it. It's going to then decompose or dehydrate into copper oxide. And in the process of doing that, creates a byproduct. And that byproduct just happens to be water. That's why we're calling it dehydration. Again, some of these things are stuff left in here because it's when we were running it. Oops, we go back one. Right, during a real lab. And actually, this is probably not the dangerous lab, but out of all the labs we do, the most that could actually harm you. So this is why there's so much safety you see popping up. But again, recording observations, if you were doing the type of this experiment, again, source of error at every step. We need to ask the question what type of reaction this is, and I'll leave that up to you. And how do we know the reaction is complete? Right? It's more difficult when you're not doing the reaction to figure out if something is, complete. The idea here, and I'll have to give you the answer for that one, this compound is blue, this compound is black, and then water and heat obviously are clear. So how am I going to know that the reaction is complete? It's going to have to be done, it looks like the wrong word, a color change is the only way I would know. Reaction 4 is to take that black product that I had in the last reaction, that copper oxide, treat it with some clear colored sulfuric acid, and what it will do is create a new compound. In this case, copper sulfate, which will be blue, and then you have your clear water. So again, what we're going to see is another color change. Maybe we should get rid of this double-headed arrow. That black product is going to convert into blue. Right, again, this is more information on how to run it if you're actually doing this, but again, you're going to see the same bullet points that we saw on everything else, right? Again, I'll leave it up to you to figure out what type of reaction this is, right? But how do I know if the reaction is complete? Well, from this one, we know because we have some kind of black solid. If that black solid completely disappears and I'm only left with the blue solution, well, that's how I know it's going to be done. This is all gone. Everything now is in the form of copper sulfate. So usually this is done as a 2-week lab, and I believe we're going to hold to that schedule. I'll send out more information on that shortly. So forget this slide right now because it's about actually finishing the experiment. What we are going to work on this week, and I will send out additional documents on this, is writing a method section. So not doing this particular reaction really isn't a disadvantage because you've been given the method anyways. It's learning to take paragraphs and systems of steps that you've been given and then turn them into a succinct method section. So it is going to be required that you write a full procedure, especially for each reaction. And that's going to be for 5 reactions total. There's 5 reactions in this cycle, right? It is not bulleted. It will be in paragraph form. I know your protocols that you write in your own notebooks are bulleted. A materials and method is a formal document, and it must be in paragraph form. Things that are new, it's a very different tone of voice than we're used to. You need to write in third person passive voice. So what I have down here is 4 different examples. I'm not going to read through all of them. Read through them, speak them out loud if necessary, but feel the difference in the tone, right? The correct tone is going to be the one here. It's dry and to the point. It is not a command, and it's talking in the past, right? So we can already see, I can immediately, without even reading the whole thing, I combined. Well, that's description. That's first person. So we've already broken the third person rule. Combine a 1/2 gram. That is a imperative command. It is a command. It is not passive. A 0.47 gram sample of copper metal, followed by 4 mils of nitric acid at 16 molar concentration, were added to an Erlenmeyer flask. Third person. Passive voice. It is not a command. It is passive voice saying this was done with nothing special, and it was in the past tense. And then this one down here, I don't even know. Like, if you read that, it's not even correct grammar. It's just more to like starting in the middle of a sentence. So you can see why that one's wrong as well. So it takes some time, but basically, if you feel like you wrote something super boring, it probably means you did it right. Or at least you're heading in the right direction. I'm just going to finish this off because it's only a couple more slides. What we would usually do is divide this into 2 weeks worth of labs, but again, remember, actually, what I'm going to do is I'm going to skip through a bunch of this because I will send out another slide deck next week. So we're going to skip all the recap and all the safety. What I do care about is going to be reaction 5. So again, this is going to be completing that cycle that I was talking about. The very last part of the cycle. So usually we would stop when we have that blue copper sulfate solution. What we're going to do is take copper sulfate, react with zinc to create zinc sulfate. So this is going to be basically a shiny metal. This is going to be blue. This is going to be clear. And this will be obviously copper colored because it's copper solid. So this is going to help us answer, how do we know it's done, right? So again, we've got to make sure we're doing all our observations, record any sources of error. So I know you haven't done it, but you need to think by looking at the procedure, what could have gone wrong? Was it designed to be as successful as possible, right? So again, I'm going to leave this up to you. I will eventually send out an answer key. I know I keep saying that. I will leave it up to you. Eventually, there will be an answer key. What type of reaction this is. Again, how do I know this reaction is complete? Well, that's actually not too bad. We went from blue to clear, and I went from a shiny zinc metal to copper zinc metal. Or sorry, not zinc metal, but to copper colored metal. So that's how you know it's done. This one, I'm going to leave up again to you. Read through the protocol. There's a reason why we're adding hydrochloric acid. So make sure you read through that. So the very last thing we'll need to cover, this might be, well, we've done it before, but this might be the first time we're reporting it in a method inside a lab report, is percent recovery. Usually what we do is percent error. And that's at theoretical over experimental, right? Actually, percent recovery is way easier. How much did I start with and what did I end with, right? Because if you started with 1 gram of copper and you ended with 1 gram of copper and I multiply that by 100, well, that means I got 100% back, right? If I got 0.8 grams back and I started with 1 gram, I would have had 80% back. It's as simple as that. So forget this. Some of these are just mixed in with old slides. I'm sorry, I've tried my best to go and curate them. I just want to make sure I'm not wasting your time. All right, great. So we're at the end of this. So that was our pre-lab lecture. I'm going to send out an email detailing exactly what I need for next week. You have already received an email on what I expect to be uploaded to on Thursday. So when I'm recording is tomorrow, but because today's Wednesday. But Thursday, March, what is that going to be? Let me just look at my phone. March 26th, 12:05 p.m. I've already sent you a document. You know exactly what to do. Make that a priority. I will be on Zoom tomorrow, again, at the 26th of March at 11 o'clock. Look out for an email. I'll send you the link, and then we should be able to have video conferencing if need be. All right, stay safe, stay healthy. I will talk to you tomorrow.